Hey there. So, I'm going to talk to us about the importance of importing data because it is very important. Yep. Also, I apologize for the lighting. It looks weird. And it does because it is later in the day than I usually record. So, let's just dive in. Okay. There we go. So first we're going to start with reading in rectangular data into R. So there are a couple ways to do it within the tidyverse. One is readr, which reads in most data types, CSV, DAT, and a couple others, as well as readxl, which deals more with some proprietary data file structures like Excel. Is one, there are a couple others. But those are the two primary tidyverse ways to read in data. So using readr, here are some of the many functions. So we have read underscore CSV. This is for comma delineated files or delimited files. So essentially each column is separated by a comma. And we've got read CSV2, which uses semicolon based files. So in countries where the comma is used more as a decimal place, so Europe and most places that are not America. So you may be working with data from all over the world. And so being able to read in semicolon separated files, important. TSV is tab delimited files. What? All right. I have to make room. Now? Yeah. All right. No? Come here. What do I want? Use your words. I don't know. There we go. Up. The desk is a little filled with film equipment. Hi, Tukes. Okay. So that we can actually capture some audio. I'm going to take off this. Awesome. Cool. So yeah, let's keep diving in. We've got read TSV, so that's tab delimited files. We've got read delim, which is kind of a broader case where you can read in files with any delimiter. Read FWF, so these are fixed width. SPSS uses a lot of fixed width, and so each column is indicated by a specific amount of character space. Got read table, which uses common variations of fixed width files that are essentially columns separated by white space. There are tons and tons and tons of these. All right. So here's an example. Hi. So we're going to read in the Nobel data. You're pretty familiar with this by now. So what I did is I spit it all out here. And so it gives us a ton of information about this data, including the name of the file. Let's see if I can get the mouse to, yeah, so we got the name of the file or the data frame. We got the number of rows, 365, 930, 935. I cannot read. I don't know. We've got column frequency types. It gives you a ton of information. It spits out the tibble, giving you some summary statistics, white space, just tons of stuff. I encourage you to crawl in to get a nice sense of what's going on. All right. So that was reading a file. Now let's try writing one. So, we can make a tribble, which is essentially a data frame. All right. So here we're writing a file, and it is giving us many, many warnings. So we can essentially just do the reverse. For every read underscore, there's a write underscore. And so here, the old school version, the one that I am most used to, gives you a nice little warning that instead of path, you should just name the damn file and just tell it where it is. So, yeah. So let's check to make sure it got written out. I'm gonna write a file. Whatever. This you get to experience anyway. Actually looks fine. We'll fix it. Panes, show panes. Alright. Let's go find this table. Cool. Okay, cool. Yeah. Nope. I'm going back this way. Cool. So yeah, I think that's it for now. Okay. Where were we? So we can write out our file as a data frame and spit it out using file equals. You'll notice there have been some major revisions in Tidyverse in the past since I tweaked my slides. So yeah, cool. So now we can go check and just see what data is written in that file. You'll notice there's a little bit more data because I've already run this. But in theory, it does tell us that data df is here. So your turn. So I want you to go into that application exercise 6 and open the Nobel's CSV RMD file and knit it up, read through it, and then go break it down by STEM and non-STEM. So I want you to create a new data frame named Nobel STEM that filters for the STEM field, so physics, medicine, chemistry, and apparently economics. Then I want you to create another data frame, Nobel non-STEM, that filters for the remaining fields. Write them out and save them to data. So hint, you might want to think about using the in operator while filtering. It's a good one to know. So yeah, I'm going to pause while you do all that. Now that Tuki's gone. Oh. Okay. Well, you go work on that. I'm going to go fix the fountain because apparently that's what Tuki wanted. Because the fountain makes noise. Hiya. Okay, cool. Not cool. Okay, so we're back. I'm back. Hopefully you finished up. And if not, why didn't you just pause? So, cool. You did all that. We're going to keep going. We're talking about variable names now. Ladies and Jonathan. And future students who aren't in the first iteration. Cool. So, variable names. So here we're going to read out our data from Edinburgh Airbnb. And just read it out, assign it to Eddie Airbnb, and then spit out those names of the variables, just so we can see what's happening. Here we've got ID, price, a British version of neighborhood, accommodates, number of bedrooms, number of bathrooms and beds, number of reviews, listing URL, and review score ratings. And price, in case I didn't say that. Cool. But guess what? R is an unhappy baby. And so if you try and plot some of this data and just use the raw variable names that it comes with, like number of bathrooms, and just plot that and do a nice scatter plot of bathrooms by price, R will complain and give an error that kind of looks like this, where it just says unexpected symbol. Well, what the unexpected symbol is that space, because it doesn't know what is happening here. So you need to either fix your names, or there's another trick. So option 1, we can define our column names. So we can, when we import our data, we can assign column names and just add a vector of strings that matches up, that are nice, don't have spaces, aren't weird with capitalizations, stuff like that. And we can just spit them out. And as we can see here, we've got all 9, 10 of those, and they all nice, organized, usable. Or we can format them and just clean them up. So we can use janitor, and the default just turns it straight into snake case. It lowercases everything and replaces spaces with underscores. And it works pretty well because we just pipe our variable into janitor. So that's option 2. So that's it for this little video. I'll see you in a bit. So bye-bye.